Hi everyone, my name is Alicia Henderson and I'm a Masters by Research student at the Montfort University, where I've been working alongside Dr. Nicholas Turner and Dr. Rachel Hand on anabolic androgenic steroid and selective androgen receptor modulator detection via molecularly imprinted solid phase extraction coupled with HPLC analysis. The prohibited list published by WADA annually shows anabolic agents in category S1, and this category has shown to be the one with the most cases of misuse in sport. Within this category, anabolic androgenic steroids have traditionally been the primary choice for misuse. However, selective androgen receptor modulators, also known as SARMs, are upcoming anabolic compounds that pose a new threat to anti-doping analysis, and this is due to their structural diversity. Anabolic steroids typically share the same 4-carbon ring backbone, and the functional groups that surround this backbone have very little variation. SARMs, on the other hand, share the same benzyl alcohol core, and the functional groups that surround this core are extremely diverse, which leads to compounds with varying properties, which can be challenging at the analytical stage. And in addition to this, the appeal for SARMs comes from the minimal side effects shown in comparison to anabolic steroids. And this has caused SARMs misuse cases to increase, which means improving and updating detection methods for SARMs is important. Molecularly imprinted polymers, also known as MIPs, are artificial materials that display selective recognition of a target molecule. The synthesis of a MIP comes from the polymerization of functional monomers, a template molecule, and a crosslinker, which enables cavities to be formed that are complementary to the template. And it's these complementary cavities which allow selective rebinding and selective recognition of the target molecule to take place. The selectivity of MIPs allow them to be compatible with and help improve current detection methods that are used in anti-doping analysis. And an example of this can be seen in molecularly imprinted solid phase extraction, where the use of a MIP as an SPE sorbent allows an improved alternative to traditional SPE, and this is due to the selective recognition abilities of the MIP. MISPE can be used prior to HPLC analysis to pre-concentrate and remove interferences from the matrix, which is useful in anti-doping analysis where samples such as urine contain complex matrices. In this project in particular, 3 anabolic steroids, testosterone, stanozolol and gestrinone, alongside 2 SARMs, ligandrol and RAD140, were used as templates in MIPs synthesized for MISPE. And a solution of the target molecule was added to the SPE cartridge at the loading stage, and the elution solvent was analysed using HPLC analysis. The results of the study showed sufficient percentage rebinding between 45 and 93% for each MIP. And alongside the MIP, a non-imprinted polymer, also known as a NIP, was also evaluated as a control. An imprinting factor, which is a comparison of the performance of the MIP to the NIP, was also calculated, and these values varied from between 1.57 and 0.92. An imprinting factor of above 1 shows selectivity of the MIP, as the performance of the MIP is greater than that of the NIP. And RAD140 was shown to be the most efficient MIP, with a percentage rebind of 93%. So to conclude, The MIPs synthesized have each shown good affinity for their respective target compounds, and this is shown by the efficient percentage rebinding, which also shows the potential of the MIPs to successfully act as an isolation material. In the future, kinetic studies are to be carried out with different concentrations of loading solution, which will involve the calculation of a dissociation constant, which will help evaluate the rebinding abilities of the MIPs and also help determine a limit of detection. The MIPs synthesized in this project so far are the first iteration of polymers, and so the next crucial step of this project is to carry out molecular modelling of the polymer design, which will help improve the performance of the MIP as a result. Further work will also include the use of urine as a loading solution to simulate the complex matrix seen in anti-doping analysis. And for me personally, the next step of this work in my master's project will be the synthesis of MIPs on the nanoscale for recognition via a biosensor using an SPR platform. Thank you for listening to my poster presentation today.